Hypothalamus artificial intelligence. Digital transformation powered by real-time autonomous and intelligent algorithms. Hi, Cisneria and Gurobi invite you to visit their stand during the Latin American Ports Congress to be held in Santos, Brazil, at the end of November 2022. Hypothalamus artificial intelligence, Cisneria Engineering and Gurobi Optimization have agreed a technology alliance to provide services to complex industrial enterprises using advanced mathematical models. Their technological capabilities, in artificial intelligence and mathematical programming, make them the ideal partners to face the challenges that exist in advanced analytics applied to transport and logistics sector. This alliance is particularly strong for the optimization of planning and operation of ports, aviation industry, and rail systems. The main success case in the port sector is berth and services planning and scheduling at Port of Cartagena de Indias. The main characteristics of the project are: the challenge, to implement large-scale mathematical models to optimize its operations and commercial services. The solution, implementation of a set of optimization models for the definition of operations timetable, and the allocation of ships to docks and cranes to ships, to optimize the management of the two terminals of the Port of Cartagena. The result, the mathematical models allow to optimize operations of the port for planning terminal services assignments, planning big events in the port, and analysis of commercial opportunities. HI has developed the HI Port System to optimize the decisions of companies related to the port sector and the logistics operations that must be faced. The optimization applied to ports can be organized into 4 hierarchical levels, covering the following activities. Strategic level includes terminal allocation and capacity planning. Medium-term tactical planning includes berth allocation, macro yard planning, and maintenance of equipment. Short-term planning includes stowage planning, key crane assignment, auto-loading/discharge, yard micro-planning, manpower scheduling, vehicle routing, and maintenance scheduling. Operational scheduling includes manpower scheduling, vehicle dispatching, and stowage replanning. Below are several of the decisions that HI Port can support. First, arrival and departure of services, ships, to port, terminals, docks, quays and tugboats. The objective is to reduce waiting times for ships and penalization cost in the harbor. The model produces the detailed activities timetables and show them in a smart Gantt diagram. Second, allocation of gantry and mobiles cranes to services. The objective is to optimize the loading and unloading of vessels and maximize key crane usage. The model considers sequencing of cranes, choice of cranes key, clearance constraint between consecutive cranes, sequence and no overlap constraints, crane sharing between 2 ships, and movement constraints for bridge and derrick cranes. Third, port assets maintenance activities. The objective is to minimize the maintenance cost. The model considers assets, key, gantry and mobile cranes, yard cranes, spreaders, and internal tractors, and maintenance and operational activities planned jointly. PHM considerations. Scheduling of maintenance tasks on a several weeks horizon, including allocation of staff and equipment, and sequencing and timing of maintenance tasks. Fourth, allocation of labor to activities in the port. The objective is to assignment of timetable of human resources, minimizing the number of employees hired and reducing the cost of payroll. The planning is carries out considering the pre-planning of port operations. Fifth, assignment of containers and vehicles to storage yards. This process is carried out in 2 stages. Stage 1, yard macro planning. The objective is to minimize the congestion in the yard for loading and unloading. The model considers optimization based on the cluster's concept, connection with the future allocation of ships, and yard crane constraints. Stage 2, Yard Microplanning. The objective is to find quickly a stacking plan for a set of containers. The model decides for a container which cell across several clusters. The optimization of container storage considers cluster defined by macro planning, cells defined by microplanning, pre-assigned clusters, like used for transshipment containers, grouping containers considering destination, size, category, weight, and cranes constraints when stacking up. Sixth, movements of containers and vehicles between ships and yards. The objective is to assign the container to the crane as close as possible. Constraints of the model are handles the loading sequence between the yard and the vessel, location of containers and vehicles considering the future planned movements, constraints on cranes, clusters and on weight and stability and ships. The real-time decisions are which slot in the vessel, which cluster to pick in yard. Seventh, planning and scheduling of bulk port terminals. The objective is to minimize the terminal operating cost, considering the system environment which may include the fuel cost of ships. Managing bulk ports and ships becomes part of the industrial process, since it defines the supply of raw materials and the distribution of finished products that are related to industrial operations. Depending on the specific case, it must be coordinated. The arrivals with consumption in industrial plants, the departures with production in industrial plants, and the storage is level with the output of material. The optimization may affect the industrial process's speed and the ship speed. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.